Hi, middle three. We were going to talk about the first lesson here, which is force and motion. But at the beginning of the lesson, we want to know what's meant by motion. In fact, motion, for example, in this slide, we can see a car A. The car A is moving from its position or its place A until it moves till the position B. Okay, so the motion is the change in the object position or location. This is the first keyword, that. The motion, it means that the object change its position, for example, from A to B, as the time passes according to the position of another fixed object. For example, if you consider this building is a fixed object. So, what's meant by motion simply? Motion, it is the change in the object position. So this is the first keyword. As this car, for example, moved from this position to B position. As the time passed, this is the second keyword, which is time, according to the position of another fixed object. The fixed object here, for example, is the building. So in this part, we are talking about a motion of an object. But what is the motion in one direction? For example, like a motion of a train. It's considered as the simplest type of motion. It's the motion in just straight line. Okay, like the motion of the train or a metro. The train is moving in a straight line. So this is called the simplest type of motion. We can describe and compare the motion of an object by describing the following physical quantity. Okay, let's read this give reason. The motion of a train is considered as an example of a motion in one direction. Because the train moves forward and backward in a straight line path or a curved path or a combination between them. It means that the train, it just moves in its path in one direction. Maybe this direction is a straight path or a curved path or a combination, but it's still the simplest type of motion. It doesn't move upward or downward. It just moves in one straight line. So it is considered as the simplest type of motion. Okay, let's understand the meaning of physical quantity. By the way, this part we are studying at the beginning of our syllabus is talking about physics. A physical quantity is anything, it's anything that we can measure. For example, if you are talking about your mass, you are, for example, 70 kilogram. Mass is considered as a physical quantity because we can measure it. If you are talking about length, the length or the distance, it's also a physical quantity. Why? Because we can measure it. So, there are many physical quantity. There are many physical quantity which we will going to study in this chapter. Let's start with number one, the speed. Speed. What is the speed? Speed of an object depends on two things, in fact. The distance it covers and the time. So let's say simply that the speed, it is the distance moved through a unit of time, or it is the rate or the time of the change in distance. What's the meaning of this? For example, we can observe that, let's see another slide. This car, it has a certain speed. This car, it has a certain speed. The car moves with 40 miles per hour. 6 hours, 240 miles. It means that this car has a certain speed. It covers a certain distance in a certain hour. Okay? So, the speed depends on two things, distance and time. So, the speed, it is the change in distance. It's the change in distance. D, it's the distance, T is the time, and V is the speed. So V equal D over T. Let's talk about this again. What's the meaning of speed? Speed. If you have, for example, a car is moving from position A to position B. The car covered, for example, 50 kilometers. Another car covered the same distance but in a shorter time. Of course, the one that covered in a shorter time has faster speed. So the speed, its definition, it is the distance moved through a unit of time. The speed depends on the change in time. The change in distance, the change in distance in a unit of time. So speed equal distance over time. Okay, calculating the speed, you should know two things, distance and time. S or V equal D over T. So the speed equal distance over time. The speed equal distance divided time. If you want the time, it's equal distance times speed. If you want the distance, it's equal speed times time. Okay, V equal D over T. T equal D over T and D equal V times T. This is called the understanding triangle. You can put your hand in any one of them so you can know its value. S or V equal D over T. D, this is times, equal V times T. Okay? The measuring unit of speed. The distance is measured in meter. The time is measured in second, so the speed is distance over time, so it's meter per second. For example, the speed of the Trisa is an animal, is 27 meter per second. The distance is in meter, the time is in minute, so it's meter per minute, like the speed of a bike, it's 30 meter per minute. The distance is in kilometer, the time is in hour, so the speed is kilometer per hour. The speed of a car is 100 kilometer per hour. The distance is kilometer and the time is second, so it's kilometer per second. The speed of light is 300,000 kilometer per second. Okay. How to change or to convert from kilometer per hour to meter per second. If you have 1 kilometer per hour and you want to change it to meter per second, it means from kilometer to meter, it's times 1000. And then from hour to minute, times 60. And from minute to second, times 60. So the ratio is 1000 divided 60 times 60. Okay, or we can simplify it. We can simplify this ratio into, for example, if you want to change from kilometer per hour to meter per second, it's 5 over 18. It's 5 over 18. Again, if you want to change from kilometer per hour to meter per second, you can do it by these steps. Kilometer, 1 kilometer equal 1000 meters. 1 hour equal 60 minutes and 1 minute equal 60 seconds. So it means it is this ratio, it means 5 over 18. 1 kilometer per hour, if you want to change it, so it's 5 over 18. You are going to multiply the number with 5 over 18. Okay. If you want to make it the opposite thing, if you want to change it to an opposite thing, from meter per second to kilometer per second, you're going to upright the ratio, 18 over 5, or upright this big ratio, 60 times 60 divided 1000. Okay, so let's say this again. If you want to change from kilometer per hour to meter per second, you will use the ratio 5 divided 18. If you want to change from meter per second to kilometer per hour, you will use the ratio 18 over 5. So, to calculate speed, we should determine two things, distance and time. Okay, let's have some questions. Number 1. What happened if the amount of speed is equal to the amount of the distance covered? It means the amount of speed is equal to the amount of distance. Let's explain this. Let's explain this. Okay, if the amount of speed is equal to the amount of distance, what happened if the amount of speed is equal to the amount of distance? It means that the time equal 1. So if the amount of speed is equal to the amount of distance, it means this value equal 1. So what happened if the amount of speed is equal to the amount of distance? It means that the time equal 1. Okay, let's go back to the slide. Okay, number 2. The object speed increase by decreasing the time taken to cover a certain distance. It means what? It means when the speed increase, time decrease. This is called inversely proportional. It means V equal D over T. So V is inversely proportional to T and directly proportional to D. What's the meaning of inversely proportional? It means when speed increase, the time decrease. So according to the law V equal D over T, the object speed increase by decreasing the time taken to cover a certain distance. Why? Because the speed is inversely proportional to the time taken when the distance is fixed. The object speed increase by increasing the covered distance at a certain time. It means that when the speed increase, the distance increase. So these two values are directly proportional. Let's repeat this again. When the speed increase, time decrease. When the speed increase, time decrease. This relation is called inversely proportional. But you should make the third value constant. يعني make D constant. طب when the speed increase, the distance increase. When the speed decrease, the distance decrease. This relation is called directly proportional. The speedometer. The speedometer is a counter. The speedometer, as you see in this slide, it's a counter used in car and planes. If the car speedometer points to 72, this means that the car speed is 72 kilometers per hour. So he want to change this value, 72 kilometers per hour, he want to change it to meter per second. Okay, what we're going to do in this? Okay, let's answer this problem. What you're going to do in such a problem? You want to change from 72, as you see here, 72, and we will going to use from kilometer per hour to meter per second. So we said that we're going to make times how much? We're going to make the ratio, we know it, times 5 over 18. Times 5 over 18 equal. So let's say this again. If the car speedometer points to 72, this means that the car speed is 72 kilometers per hour. Okay, I want to change 72 kilometers per hour into meter per second. So I will going to multiply 72 times 5 over 18. Calculated by your calculation, you will find the result is of speed, we can describe speed as number one, regular speed or uniform speed. What's the meaning of regular or uniform speed? To understand this, let's go to the next slide. This car it's moving. It covers 1 kilometer in 1 minute, and then the following 1 kilometer in 2 minutes. So between 1 minute and 2 minutes is also 1 minute. And then it covers 1 kilometer in the third minute. So each 1 kilometer, the time is 1 minute. So the regular speed or the uniform speed, its keyword is equal distance, equal time. So the equal distance, equal time, it means when the object, like a car, cover equal distance in equal intervals of time. Again, how can we describe speed? Number one, something called regular or uniform speed. When an object, like a car, cover equal distance in equal intervals of time, in equal time. This car move each 1 kilometer in 1 minute. Another kind of speed is called irregular speed or non-uniform speed. Let's understand the meaning of this speed. This car, 30 kilometer in 1 hour, and then the next 30 kilometer in half an hour, and the next 30 kilometer in quarter an hour. It means that the time is equal, but what's different? The distance is equal. 30 kilometer, 30 kilometer, 30 kilometer. It covers this distance from city A to city B. But what's different here? The time is unequal. So the non-uniform speed, when an object like a car, for example, cover what? Equal distance, but in unequal time. We can reverse this. We can say equal time, the other one will be unequal distance. So this is called irregular speed. It's the speed where an object cover unequal distance in equal time, or it's the speed where the object cover equal distance in unequal time. So we discuss how many kind of speed here. Number one, the first type is called regular speed. It's the speed in which the body cover equal distance in equal intervals of time. And the other one is, it is the speed where the body cover equal distance but in unequal time, or we can reverse it, equal time in unequal distance. Okay, let's think in some problems. A sprinter runs at a distance 6 meters per second, so this is V. Find the distance covered by the running in 10 seconds, and I'm going to give you the law at the beginning, but afterward you are going to do it by yourself. Let's go back in order to answer. Okay, let's substitute. He won the distance, so it's equal. V is how much? 6 times the time is 10. So the answer is, it's equal 60 meter. Okay, so the speed or the V, it's 6 meter per second, 6, and the time is 10 seconds, so V times T equals 60. Let's go to another problem. A train covers 50 meter D in 2 seconds. Find the speed, but in this time he wanted in kilometer per hour. At the beginning we were going to find the speed in meter per second. So we were going to say V equal D, which is distance, divided T. And we were going to substitute, equal 50 divided 2 equal 25 meter per second. So here we calculate the speed, but with what? With meter per second. طب we want to calculate it now with kilometer per hour. From meter per second to kilometer per hour. So let's say that V equal 25 times, the ratio we'll use here is either we will going to make 18 over 5 or divided 5 over 18. It's the same. Use your calculator. Yalla, do it with me. So we're going to say that 25 times 18 over 5 equal 90. So I will going to reverse the ratio here. It will be 18 over 5. The answer will be 90 kilometer per hour. Okay, let's repeat this again. A train covers 50 meters in 2 seconds. Find its speed in kilometer per hour. First, we find the speed in meter per second, and then we use the ratio 18 over 5 to change from meter per second to kilometer per hour. Let's answer another problem. A train starts to move at 6 o'clock in the morning. Then, what is the time of the arrival if it moves at speed 40 kilometers per hour to cover a distance of 200 kilometers? I prefer that you are going to write the given thing. Yani, for example, here he gave you the speed. So, this is the speed given. And also he gave the distance. So, this is the distance. He wants what from this? He wants the time. By using the understanding triangle, if you remember, speed equal distance over time. So the time equal, okay, let's see the understanding triangle to remember this. You are at the beginning. This is the understanding triangle. So you will put your hand on the distance, on the time, sorry. The time equal distance divided V. If you want the distance, it's equal V times T. Let's go back to our problem. So, the time equal D divided V. So, it's equal D is 200 divided V, which is 40, equal 200 divided 40 equal 5. So the time is 5 hours. So 5 hours, and the starts to move at 6 o'clock in the morning. He wants the time of arrival, so you will add this 5 hours to 6 o'clock. So the time of arrival, the time of the arrival equal 5 plus 6. So this we're going to arrive at 11 o'clock. Okay? Okay, you're going to try to answer the homework. You're going to try to answer the homework. The homework is until slide number. This is slide and also this slide. Okay. And also this slide. And this slide. Good luck. Miss Miriam.